Hello, welcome back to Math at Marvin's. Okay, hello geometry students, how are you guys doing? Okay, first things first, got a lot more assignments turned in via email. A lot of your houses look good. I saw some of you just said, hey, I couldn't do the house, but I built the figures. Also awesome. Okay, not grading it based on how perfectly you did it. I just wanted you to get a little better at geometry or GeoGebra, sorry. So that way we can use GeoGebra. Great tool for us. You guys did a very good job being persistent, trying things, testing things out. Okay, I got some good questions. Remember, if you have questions, a couple ways you can get a hold of me. Email me. 2, email me and tell me you want to have a Zoom meeting. Haven't had a Zoom meeting yet. If anybody wants to meet with me face-to-face, there's a group of you. If you want to get a group of you together and go, hey, can we meet with you? All 5 of us want to talk to you about something. Perfect. Number 3, some of you have noticed I try and respond to everything you comment in the comment section. So far, been a lot of just fun comments, you guys saying what's up, telling me I should become a YouTuber. I'm working on it, trying my best here. But if you do put a comment up, I do try and respond to every single one of those, especially if it's a math question. The reason I like that is for if people have a question and you put it there, then your classmates can go there and if they had the same question, maybe just didn't want to ask it, they can get the answer from there. Okay, so make sure you're using those resources. Now let's move on to today. Today we are talking about 7.3. 7.3. I probably should write it up here somewhere. Okay, I'll put it up here in the corner. 7.3. And that's triangle similarity. Okay, triangle similarity. Okay, it's going to look really familiar to something we've already done, which was proving triangles congruent. Okay, so we're back to specifically what's going to look really familiar is the S's and A's. We're back to sides and angles and finding these shortcuts to show things are similar. Technically, we are supposed to prove. I'm going to let us take a shortcut. We're not necessarily going to prove them. You're just going to list out the information and make a statement. That way we don't have to do proofs. I know it's not your guys' favorite. You guys did really good in the beginning, so I'm okay trimming some of this up so that's more just showing you know the content. Okay? What you need for this is these 3 shortcuts. Okay, the first one, angle similarity. What this says is if 2 triangles have 2 angles that are congruent, if they have 2 angles that are congruent, then they are automatically similar triangles. Now, if you think about it, that makes a lot of sense because if 2 angles are congruent, what do we know about the third angle? Oh, we know the third angle is going to have to be congruent because they all have to equal 180, so both triangles will have the same 3 angles. Okay. So by proving 2 angles are congruent, we can state that the 2 triangles are congruent. And we just write AA squiggle. That's our shortcut. Okay? The second one is side angle side. Now that looks identical to the one we've had before because it is. But remember, we're doing something different. We're not proving congruence, we're proving similarity. Therefore, this rule's a little different. The SAS similarity shortcut isn't saying that the sides are congruent. Now what you have to do is you have to show that one of the angles is congruent. So in this case, we have D and A with the little markings they gave us. Now, of course, in our problems, we're going to have to go find some of this out. And then what you have to show is that instead of the sides being congruent, you have to show that the 2 proportions created, so here it's AC over DF and AB over DE. Okay, AB over DE. If you can show that those proportions are equal, if you can show that those 2 sides are like 2 to 3, they're both 2 to 3, like maybe one is 2 and 3, and one is 6 and 9, so it simplifies down to 2/3 on both of them, then you can say that these 2 triangles are similar by SAS. Okay, by SAS. And then our third one, this one, I'll put a little star here. This one shouldn't be new. You've done this. This is what we did from the beginning of learning about similarities. All you have to do is show that all 3 sides are proportional. That's the very first thing we did with similarity, was say, hey, make a proportion using corresponding sides. So again, big side over to the big side of the other triangle, medium side over medium side of the other triangle, and small side over small side of the triangle, and show that all of them are the same. If you can do that, then you know the triangles are similar. Now, one thing to remember, there's a possibility that maybe they're congruent. Okay, so like maybe you do angle, and the triangles are similar, but they're actually the exact same triangle. Are congruent triangles similar? Yeah, they are. Okay, so don't be wigged out by that. If I give you a problem where I just give you 2 triangles that are exactly the same and say, are they similar? You would attack it the exact same way. you would show that one of these shortcuts works, and then you would say, yeah, they're similar. I didn't ask you if they're congruent, so that fact doesn't matter. It is true, but it doesn't matter to us now. We're trying to show similarity. Okay, so I'm going to erase this and throw up some practice problems that we can go through together. All right, so here we got 2 examples up on the board. Also, some tips, some things to remember, okay, that are going to be useful. 1, vertical angles. Don't forget, vertical angles are congruent. That's where I always draw this little picture of an X and then tell you like top and bottom or left and right. Those are vertical. They're congruent. The second one is parallel and transversal. So if you have 2 parallel lines in a transversal, don't forget things like alternate interior, alternate exterior, corresponding. Same side interiors are supplementary, things like that. If you ever forget what those rules are, 1, look at your notes. 2, Google it. Okay? Man, the cool part about this online learning, you always are going to have your laptop. So flip over to Google and be like, hey, parallel lines and transversal rules. I'm guessing the first thing to pop up will be a list of them and an example of what they are. 2 is third angle rule, the fact that a triangle has to have 180 degrees, therefore you can always find the third angle if you know 2 of them. Shared/reflexive angles, okay, probably should put that in like a parentheses, okay. If two triangles have the same angle, which we're going to see in the next example, so when I go to the next board, then you'll know that, oh yeah, if they're shared, they have to be the same in both triangles because it's literally the same angle. We call that the reflexive property. And then base angles of an isosceles triangle. Don't forget that if a triangle is isosceles, there were some rules there, like the 2 base angles have to be the same also. They have to be equal. So in that case, you really only need to know 1 angle to get the other 3, or the other 2, sorry. Okay? So let's go into 1 and 2. Okay? I will tell you, these are both examples of angle. Number 1, interesting because there's 2 ways to go about it. There's 2 ways you can do it. First, you could look and go, what I think is the easiest rule is vertical angle. I know that, oh, there's 2 lines that create this set of 4 angles, therefore those 2 are congruent. Okay? From there, I know I need to start strategizing, like what am I going to use, AA, SAS, or side, side, side? Well, I don't have any sides, so it's probably not either of the last 2, so I'm messing with angles here. Okay, what's another angle I can find? Well, I can look at this and go, well, they left me these 2 markings, and if we remember, arrows on a line mean parallel. Oh, well then I have a parallel, and I actually have 2 transversals that go across it, so I can think back to this shortcut. All right, which one of these angles apply? Well, A and E are both inside of the parallels, and they're on opposite sides of the transversal, so I actually have congruent angles. Okay. The reason you can do this problem multiple ways is because you also can do the same thing with B and D, so you really didn't have to find the vertical angles. I just think for a lot of you, you see vertical angles before you see parallels in the transversal, okay? So, regardless, I now have 2 angles, okay? Sorry, it's not up on the board. I looked for it. On the last board I had up are shortcuts, angle. Okay, so 2 angles of these triangles are congruent. That means the triangles are similar. Now, here's how I want to work through these problems. 1, you're going to list everything you needed to know, and then you're going to make your statement, okay? So, first I want to list the things I found. So I had that ACB, and I should label that angle ACB is equal, or I should say congruent, because I actually don't know the measure. Angle, since I did ACB, I want to start at the same spot, so ECD. So I want to state what I know. This is you showing your work. Now, why did I know that? I want to put a little note here like, that was because of vertical angles. Boom, there's 1 piece of my work. That's 1 angle. Now 2 angles, the second angle. Depending on which ones you use, I can say something easy like angle A is congruent to angle E. All right, why was that? Oh yeah, that was alternate interior angles. So I can just write the same shortcut we used to use, AIA, alternate interior angles, and I can say, yep. From there, I now have 2 angles that are congruent in a pair of triangles that I'm trying to prove are similar, so I have enough information that I can now write my statement, triangle ACB. Now be careful, they're not congruent. They're similar to triangle ECD. And finally, I would write my step on why that was. Well, that's our new shortcut. So I would write A, similarity. And what you've done is basically a proof. I'm just not making you put it into two columns. I'm letting you just state what you know or what you can deduce and state the last statement or state what we were trying to find. Okay? I also didn't take the time to write the question up on the board. Obviously, I'm asking you, are these triangles similar? We go to the second one. Are these triangles similar? So we look up there and we go, ooh, 30, 30. All right, I got one angle that's similar. That was a given. I really probably don't even have to state that. That was already there. 55 and 65. Uh-oh. I don't have two angles, so they must not be similar. Well, I can find more information, and that's, again, where those tips come from. You don't just want to quit when there's more information to be found. I know two angles on each of these triangles. So that means I can find the third by third angle rule. So I could say something like, okay, 30 and 55 is 85. That means that I have 85 in there, so that means the last one's 95. Okay? So now I need to make sure that these won't match up. 30 and 65 is 95, so that means I have 85. Ooh. Turns out, I did find all the information. There is nothing else I can find. I can go ahead and state these are not similar. Okay? There was no shortcut. There are no sides. I couldn't find two angles. I could only find the one angle that was congruent. Therefore, these are not similar triangles. Absolutely a possibility. Okay? So that's what we did there. If that would have happened to be where it come out, like maybe that third angle would have given me two angles that were congruent, then I could have went forward. In this case, just not similar. That's okay. Okay? I'm going to erase the board quick, pause it, and then I'm going to put up two more practice problems, and then we'll call it a day. All right, here we go. Got two new problems up on the board, 3 and 4. Obviously, again, kind of like our notes in school. If you're thinking and you're going, hey, we just did two problems that were angle-angle, or not angle-angle, but were attempted to be angle-angle, you could probably guess that these next two are going to have to do with the other two we learned. Okay? So first one we have here, this is actually two triangles. If you look at it closely, you have triangle ABC and triangle DEC. So we need to think, okay, what's the way I'm going to approach it? Well, first, I need to see that, well, it looks like they both share an angle. They literally both use the same angle. That's angle C. Angle C is part of both triangles. Therefore, right away, I know angle C is congruent to angle C. We did this a long time ago. It seems like it's kind of a stupid point, but you need to state why you know that they both have an angle that's congruent. I apologize. You can probably hear Lily whining out the door. She wants to go bark at the neighbors. Angle C is congruent to angle C. Reason being, the proper reason is reflexive, as we did with proofs. I don't mind if you write shared angle. Okay, I'm going to write reflexive. Okay, so now we need to decide, what are we going to do? Well, it doesn't look like there's a real easy way to see the other angles. But if I look at the information they gave me a bunch of side lengths, okay? And remember, I need to show that if I'm going to use SAS, because it looks like I'm using an angle, so SAS would be the other option, I need to show that the other two sides are proportionate. So I would say like, okay, well, the smaller triangle is 6 over the larger, or the smaller side of this, or the smaller triangle side is 6. If I look at the whole side, well, I have to add the two together, so that's really 6 over 8. Okay? Which equals, if I divide them both by 2, I get 3/4. Now, if I go in and I say like, okay, if I want to prove the two sides are proportional, I need to show that the other side will also equal 3/4. So I do the other one, which is 9 over 12, divide both of those by 3, and I get 3/4. So now I've shown, and I should write this in like a proof statement. I have shown that EC over BC equals DC over AC. That's really what this step was. That's the statement I was going for. Okay, so remember, I'm not making you put it in a T-chart, but you do want to try and explain as much as you're doing. Explain as much as you're doing. Now I know I have two sides that are similar, or that are proportionate to each other, and I have an angle, and the angle is in between them. I might not have said that before. It's very important. The angle is in between the two sides, same as when we did SAS congruence. So now I can go ahead and I can make my statement. I can say triangle ABC is similar to triangle DEF or DEC. And I can do that by SAS similarity. Okay? So there's an example of two triangles inside of each other that have a reflexive property involved. Okay? Last one, number 4. I see here I have markings. Ooh, it looks like I have two triangles that have two sides that are congruent to each other. Oh, that means I have an isosceles triangle. So there's actually multiple ways. You actually can do this one AA. You can do this one SAS. You cannot do it side, side, side. I kind of tricked you. We're not doing an SSS. I think we know how to do that. We've done a lot of practice with that. I want to make sure we got practice on the other ones. Okay. So first thing I can do is I can look at this and go, okay, I have an angle of 40 and an angle of 100. Ooh, that doesn't really help me because those aren't congruent. But I do have an isosceles triangle on both of them. So I know something. I know the base angles, the ones opposite of the congruent sides, have to be congruent to each other. Therefore, and I should have labeled these so that way we can write a proof, or sorry, not a proof, a shorthand proof. I'll call them A, B, C, and D, E, F. Okay? Well, then I know if angle A is 40, angle C has to be 40. All right, still doesn't help us a ton. Now, if I look at the other triangle and I go, okay, I have 100, and I know the two base angles are equal. Well, in that case, all I do is say, well, there's 80 degrees left in this, and it's between two equal angles, so it's 80 divided by 2. Therefore, both of these base angles are 40. Okay? So, actually, right now, you could be done. We could say angle A is congruent to angle D, angle C is congruent to angle F, and these are similar by angle. Let's say you didn't take that route, though. Let's say maybe you did 40, 40, and then you third angled it, and you found that this is 100, which it is. Well, now you have your top angles congruent. Okay? So by the way, just to clarify, I am saying we could be done. We could have done, so this is option 1. Angle A is congruent to angle D, and angle C is congruent to angle F. Therefore, triangle ABC is similar to triangle DEF by angle similarity. And if we wanted to add a reason to why those angles were congruent, we could do base angles of isosceles. Okay, base angles of isosceles. That's why they were congruent. That's how you found that. Okay, so now we made our statement. We are done here. I do want to show the other way, though. So option 2 would have been to get the 100 at the top by doing the base angles and then finding that extra one. And now looking at the sides and going, okay, well, let's test and make sure. Well, 4 over 12 has to equal 4 over 12. They're the literal exact same proportion. So I can just make my statement and say, okay, angle B is congruent to angle E. So I'm doing that top angle first. A couple of reasons why you could have found that. You could state base angles of isosceles, because technically that is how you found that it was congruent. You also could have said third angle theorem. Any of those is going to work here. I'll do third angle. Okay. Now, if we're taking this route, then we're looking at the sides. Well, I just said I really wouldn't even need to see it, because again, this isn't about the algebra solving part. This is about showing me why they're similar. So if you just went 4 over 12 and 4 over 12, BA and ED and EF and BC are proportional, then I'm okay with you just making the statement. BA over ED equals BC over EF. Okay? And really, when you're finding proportions, there's no real reason why. You're just finding proportions. So I'm okay with you leaving that reason blank. Or if you showed your work somewhere, do not put your work in here. I kind of did a bad example here by putting it there. But if we put our work over here, that's fine. Like the 4 over 12 equals 4 over 12, or 1 over 3 is 1/3, whatever you want to do. But this statement is true. We know that. So now we can end with our triangle statement. So triangle ABC, similar to triangle DEF. And that one is by, in this case, would have been SAS, similarity. Okay? So, that's what I got for you for today. I'm not even going to give you any practice because come Friday, I'm going to have an activity with you. What you need to do to get ready for that is you need to find a little mirror. Best example, what I'm going to use is one of my wife's makeup mirrors. Okay? One of those little circle mirrors. You need something small that I won't give it away. We're going to do an activity that's actually kind of fun. I think it's kind of sweet. That has to do with similar triangles and finding the height of objects. So, find a mirror for me. You also need a tape measure. And then if you're doing it by yourself, you're also going to need some tape. Or actually you don't need tape. You need a random object to put down where you are so you know distances. Okay? Otherwise, that's it for today. That's 7.3. Remember, leave me a comment if you need something. As always, slap the like button. Give me a subscribe. Help my career take off on YouTube. Between the 30 of you that watch this. Otherwise, let me know if you need any help. Let me know if you guys want to have a Zoom meeting, if we need to go over some stuff. If you're still stuck on the house project, the house assignment, definitely get in contact with me. Otherwise, enjoy your time. Find something to do. Enjoy. Stay busy.